Good morning. In this session, today let us discuss about the linear measurement. The measurement systems are mainly used in the industries for the quality control and inspection. So the engineers more oftenly use some measuring systems. So they are broadly classified into two: the linear measurements instruments and the angular measuring instruments for the inspection work. So there are many measuring instruments are used to compare the actual dimensions with the existing standard dimensions. So now to start with the linear measurements. It is normally concerned with the measurement of diameter, thickness, height, thickness, length. So these are come under the linear measurements. So the linear measurements used to find the distance between the 2 points on a straight line. Here, it is divided into two. The one is the line measurements. That is the distance between the two lines of measure is measured. And end measurements, he discovered the distance between the two surfaces measured. So for the linear measurements, there are many instruments, as you know, Vernier caliper, Vernier depth gauge, Vernier head gauge, depth gauge, and screw gauge. These are some commonly used instruments for the linear measurement. Now, let us know about something about the Vernier scale, Vernier caliper. Here, in the Vernier caliper, as you see in the diagram, it mainly consists of a main scale and a Vernier scale. Here, there are some the main scale division is main scale division is 1 mm, and that bottom the Vernier scale. So in the Vernier scale there are 50 divisions, but the length of the 50 divisions is only 14 mm. So there is the difference between the divisional value between main scale and the Vernier scale is existing. So from the difference, the accuracy is maintained. Here, normally in the main scale, one main scale division is 1 mm. Here, there are 50 divisions, and the 50 divisions measure the length of 14 mm. So the one division in the Vernier scale is 49 divided by 50. Okay, that is 0.98 mm. The instruments, normally a term is used called least count. So the least count is the lowest value or shortest value that can be measured accurately from a measuring instrument is called the least count. In the Vernier caliper is concerned, the least count is the difference between the one main scale division and one Vernier scale division. That is 1 MSR minus 1 VSD. Okay. So one main scale division is 1, then one Vernier scale division is 0.98. So the least count for the Vernier caliper is 0.02 mm. So other than that, as you see in the photograph and the diagram, the Vernier caliper consists of the main scale and a Vernier scale. Other than that, the two jaws at top and bottom. Here, the top measuring knives or jaws used to measure the internal surface or internal dimensions of a object. Here at bottom also, two blades are there. One is fixed and another is movable as in the top. So these jaws are used for the measurement of outside measurement. Other than that, there is a blade which is bottom of the scale. So the measuring blade is used for depth measuring. So the depth also can be measured. Now, how can we read the measurement? So for example, an object is clamped gently in between the measuring jaws. Now, the value to be read like the total reading is the main scale reading. How many divisions completed in the main scale divisions plus the number of Vernier scale divisions that coincident with the main scale divisions multiplied by the least count. So the total reading is main scale reading plus within the bracket the number of Vernier scale division coincide with the main scale reading multiplied by the least count. That is the value, the actual value observed. Similarly, the screw gauge or micrometer, as you see in the photograph and the diagram, the micrometer or screw gauge consists of a fixed frame in the U shape. So at one end, anvil is fixed. So the anvil is fixed, remember, and another side, in the barrel is attached. Inside the barrel or thimble, a screw rod is there. So the screw rod is extended with a spindle. Whenever we rotate the thimble, the screw rod also rotate and move the spindle from left to right. So the spindle can be traversed from left to right or right to left. Here, the barrel consists of some scale divisions called the main scale, and the sleeve, the barrel transfers along the sleeve. So the sleeve has some scale divisions, which is called pitch scale. So main scale and a pitch scale. Normally, the screw thread inside the thimble has 0.5 mm pitch. So for one complete revolution of the thimble traverses by 0.5 mm. That is equal to the pitch of the screw thread, that is 0.5 mm. Here, in the 50 divisions for complete revolution, just move the barrel by 0.5 mm. So one division in the thimble is 0.5 divided by 50 division, that is 0.01. So that is the least count in the for the micrometer. Okay. So the 50 mm is divided into 0.5 mm length. So entire 50 divisions can be rotated in one complete turn, and the barrel traverses by 0.5 mm. So one divisions in the barrel equals to 0.5 divided by 50. That is equal to 0.01 mm. That is the least count of the micrometer. Okay. Now, normally the micrometer may have some error. Here, when the anvil and the spindle is in a closed condition, so the zero of the sleeve, that is the pitch scale, and zero of the main scale should coincide. So it indicates there is no error, there is no zero error. But instead, in the zero of the there are, for example, if there are 3 divisions ahead in the main scale from the datum line in the pitch scale, that is plus 3 divisions error. Okay. Now, while calculating the reading, we have to subtract the plus 3 division. That is, the plus 3 divisions error can be balanced by subtracting that is 3 divisions equal to 0.03 mm. So we have to subtract the 3 divisions value, that is 0.3 mm from the actual dimensions measured. Okay. Here, similarly, Vernier height gauge, it also consists of the main scale and the Vernier scale similar to that. So it consists of a base, and the central is a beam which carries the Vernier scale arrangement, and the Vernier scale arrangement consists of a clamp. So in the clamp, end of the clamp is adjusted to a scriber. So the scriber touches the surface to be measured. Here, the graduated scale directly slides through the base, but the Vernier scale remains fixed as shown in the diagram. So from that, we can measure the height of an object or depth of an hole or depth of the recess. These can be measured from the Vernier height gauge. So the least count and the reading of the value is similar to the Vernier caliper. Thank you.